A number of years I've had kids draw what they think a scientist looks like. It's something teachers tend to do. And you'll see a frizzy-haired white man in a lab coat. And so today we had people of all colors, and we had men and women, and people speaking with different accents. So that's really neat for them, because our kids are very diverse here, so they can see that scientists could look like them.
I know when I was senior in high school, I was trying to decide what I wanted to be when I grew up. If I had had more opportunities like this, it might have been an easier decision.
When I was a kid, I wanted to be a veterinarian because I didn't know anything else was out there.
I myself kind of always wanted to be a scientist. I just changed up which kind of scientist I wanted to be as I was growing up.
The reason I do it is because I wish somebody did it for me when I was in school. That's my primary motivation. Whenever you can take real engineers and scientists and bring them into a classroom and let children know that real people do these kind of things right here in your own backyard, I think it makes science more real to them.
Over and over and over again so that we can power our lights.
The CAER 101 Education Project grew out of a 12-year-old outreach partnership with Russell Cave Elementary, where center scientists brought hands-on experiments to fourth grade students. Jack Groppo, who has been part of this project since the beginning, says CAER 101 has 3 goals: get scientists into classrooms, provide experiments that teachers can easily duplicate, and challenge other groups to do the same kind of outreach.
If we've got something that's pre-packaged, that it's just a matter of copying it, we'll give you the resources, find a school in your neighborhood and just go do it. It doesn't take that much time. It's a phenomenal benefit to the teachers and especially the students.
In 2014, CAER expanded the project to 3 Lexington elementary schools: Russell Cave, Liberty, and Yates. CAER scientists presented the same 1-hour lesson to each of the 3 schools. Their goal was to convey disciplinary core ideas, part of the new science standards.
So our lesson was, what is energy? And we were demonstrating sound energy, light energy, and electrical energy. We had a coffee can that we put a piece of paper on, so we would tap our fingers on that. Or we had a tuning fork that we would hit and put underwater up to our ear.
My lesson basically is demonstrating how collisions work. I actually built what's known as a Newton's cradle, which you might have seen the little desktop toys that have the balls that clink back and forth, but mine is a little bit bigger. The energy is always getting transferred around, it doesn't just disappear. It certainly allows me to really teach the principles that I'm trying to get across in a very visual and hands-on kind of way, and impart some of the principles of the scientific method in doing so too, i.e. in the repetitiveness of what you're doing to make sure that you repeat the same experiment to get good data.
My lesson was how electricity is actually produced. We just basically had a pole with the magnet in the middle, and it actually had copper wire on the outside, and you could flip the magnet in the middle really fast, and you could actually show them on a multimeter that electricity was produced. We took a hand crank and took it onto a hobby generator, and we used that to power fans and lights and buzzers.
I think they really enjoyed it. There was a lot of laughing and having fun. A lot of questions, which is always great.
I like research because you're solving problems. That's what you do with research. Once they got into it, they really had good questions. They wanted to know, well, why does a number sometimes go negative? I would get really excited, really pumped up because you could tell the kids were interested. I'm sure that's what teachers really enjoy, is when they see they're getting through the kids, or the kids are interested in what you're talking about.
It's really impressive that I can use this thing to hold 4th graders' attentions with physics lesson for an hour or so and actually impart some really good information.
At the end of the academic year, we'll sit down and we'll get the real criticisms. Number 1, was it worth it? Should we do this again? I believe the answer will be emphatically yes. And okay, if so, how do we make it more instructional? Where were we off on our vocabulary? Which one of our demonstrations worked well? Which ones didn't work quite so well? Are there any other topics that we can add to it?
CAER is field testing these lessons here, but where they're really going to be essential is in the classrooms in schools that don't have science labs or don't have the kind of equipment that we have. By a long shot, really the best way for kids to learn. It's more engaging. They'll remember it. They'll get it. It's fantastic to have them come in.
I think it helps give the kids a real-world connection to what they're studying in class, to see how it's actually applicable to the everyday world, gives them ideas for what they want to do when they get out of school.
If we can get 1 or 2 kids to actually seriously consider going into engineering or science as a profession, it's well worth it.